Hey students, welcome back. So we are here to review all the important chemical reactions involved in the chapter Study of Compounds Nitric Acid. Again, just like sulfuric acid, nitric acid is a very important compound as it is a very strong oxidizing agent. So let's see all the reactions related to the property of the nitric acid being a strong oxidizing agent. So let's move on. First, as usual, we are going to start with the preparation of nitric acid. So how do we prepare nitric acid in lab? Let's see. So we use the salt, potassium nitrate in presence of concentrated H2SO4 and see the temperature less than 200 degrees Celsius. And what is formed is KHSO4 and HNO3 nitric acid. This we also saw in the reaction of sulfuric acid, right? How sulfuric acid reacts. Now we are here to see the formation of nitric acid. So obviously we are going to use the nitrate salt of potassium. Clear? And this is how we get the vapors of nitric acid. See the temperature less than 200 degrees Celsius. Okay. If we use sodium salt, same reaction H2SO4, here the salt will be different. You will get sodium salt, sodium hydrogen sulfate and HNO3 in the vapor form. Let's see the decomposition of nitric acid, how it decomposes. So your nitric acid decomposes to form nitrogen dioxide gas, water and oxygen gas. In sulfuric acid, we saw the formation of SO2 gas as the main one, right? Here we have oxygen gas and NO2 gas. Remember this. Okay. Let's see the oxidizing nature of your nitric acid, how it gets that oxidizing nature. Let's see the reaction for that. So, first of all, we see how it decomposes, right? So, this is the first is the decomposition reaction of your nitric acid, H2O, 2NO2 plus this nascent oxygen is the one responsible for making it a very strong oxidizing agent. Then let's take copper and this nascent oxygen will react and it will get oxidized to form copper oxide. Then copper oxide will react with HNO3 to form what? Copper nitrate, okay, the salt copper nitrate and then this H2O. So let's see what are the common things here. Oxygen gets cancelled, correct? Then your copper oxide gets cancelled. Let's see the final reaction. Copper plus 4, can you see 2 and 2, 4 HNO3, okay? CuNO3 twice, that is your copper nitrate plus your H2O, how many H2O? 2 H2O, one here plus your 2NO2. Okay, so this is the final reaction. Let's continue with the oxidizing nature of your nitric acid. When you take copper and your nitric acid, concentrated nitric acid, you get copper nitrate plus your H2O plus NO2. Let's take the carbon, coke. So C plus 4HNO3, okay, concentrated will form what? Carbon dioxide. So see, it got oxidized in the presence of your nitric acid. Then what will be the result? As usual, water, and this is common, okay, NO2. Only the number of molecules will change. Yeah, sulfur. So copper, which is the metal, done. Let's take two non-metals. Next is sulfur. What will be formed here? H2SO4. Okay, we got sulfuric acid, we got water and we got nitrogen dioxide. Clear? When we used sulfur with, when your sulfur got oxidized with HNO3, it formed sulfuric acid. So let's take the next reaction. C7H8, your methyl benzene reacts with your, or your toluene reacts with your HNO3, that is your concentrated nitric acid, reacts to form dinitrotoluene. C7H5NO3 twice plus 3H2O. What is important here is the oxidizing nature of this. Okay, how it is oxidizing this compound. Clear? Next we have this brown ring test which detects the presence of nitrate ions in a compound. Okay, so what is the reaction of the test? That is important. The theory you know. Let's see the reaction. So you have to put iron sulfate FeSO4, slowly add H2SO4, concentrated H2SO4, then there is HNO3 or nitric acid, and what will be formed? 3Fe2SO4 iron sulfate plus H2O plus your NO. Correct? So this is the reaction for your brown ring test, remember. Then FeSO4 plus this NO will give you FeSO4.NO, nitrosoferrosulfate. Okay, so I hope the reaction for this test too is clear to you. I hope all the reactions from your compound nitric acid is clear. So keep revising, keep learning. Thank you.